Hello, welcome to a coding challenge. I am just thrilled to be here. I have had a wonderful invitation from my friend Grady over at Practical Engineering to work on a simulation of horizontal directional drilling. Now, if you had asked me a year ago, hey, are you ever going to do a coding challenge about horizontal directional drilling? I was like, first, what's that? And probably not. That doesn't sound like a thing I would do. But after some research, after being taught about this from Grady, I am just fascinated. And I think there is potential to create a fun, playable 2D casual game where you are the horizontal directional driller. So what is horizontal directional drilling? Well, you don't need to listen to me explain it. I've linked to Practical Engineering's video on the topic. It's very well researched, gives you lots of context and backstory, as well as many amazing demonstrations of doing it on big and small scales. Grady was also kind enough to send me this diagram, which sort of shows a scenario of how it might play out, with a whole lot of suggestions for how this could be turned into a game, from practice mode, hard mode, and other ideas. I'm going to try to take all of that and synthesize it down into the simplest case scenario, diagram it here on the whiteboard, and then code it up. All right, my artistic skills aside, here is the scenario we're dealing with in an overly simplified manner, especially given the fact that this is completely two-dimensional. We need to run some pipe from point A to point B. If there were no river, we could just excavate, drop the pipe in, and backfill it in. But this river is here, and also maybe there's some other restrictions that we can't dig up all the land. So could we sort of thread the needle, so to speak? How could we just thread a pipe in and curve it around and steer it? That's what horizontal directional drilling does. Now, it involves all sorts of real-world considerations, and drilling fluid and materials. I'm not going to concern myself with any of that. I'm just going to look at the mechanic of how the controller steers the drill and create a simulation mini game out of that. Now, again, I have very little real world experience with this, but a regular drill, the drill bit might just look like this. Obviously with some ridges and edges and markings and stuff to make it, cut into things. For horizontal directional drilling, also sometimes called directional boring, the drill bit itself will usually have something askew at the end. We can think of it as like, oh, it comes off and it kind of points down. This is what gives it a bias. So as it's going into the ground and drilling, this bias will cause it to curve down so that the drill, as it's inserted, it could start curving down. In a 3D world, this bias might be something that we fully rotate, but here in our 2D scenario, I'm just gonna think of it as either pointing down or pointing up. So pointing down for -1, and we could flip it to pointing up. If I flip it pointing up, it's going to start to curve the other way. The drill is always turning. There's no way for it to go straight. So the challenge is, if I have a drill that's always turning either up or down, left or right, on or off, +1, -1, how can I effectively steer it through a complex path? There could be all sorts of other stuff in the way here. There could be other lines we don't want to interrupt, strange rock formations. I don't know what's underneath the earth and what engineers really deal with, but we've got to be able to get some kind of control over steering this. I think we've got what we need, though, for me to be able to get started coding. Here's the base code I'm going to start with. Now, if for some reason this is the first time you're watching the coding train, hello, welcome! This is P5.js, a JavaScript framework for creative coding. I use it in almost all of my videos. If you've never coded before, I do happen to have a complete intro beginner series. There will be things in this video that you don't understand if you haven't coded before, but I'll try my best to walk you through it, and then you can always refer back to some of my intro videos to fill in the gaps. When I'm starting with the same scene here, a canvas with some ground and a river, and my drill is going to start somewhere around here on the left. I'm going to use P5 vectors as the main data structure to keep track of where is the drill and what direction is it moving. So first thing first, a position variable for the drill. And I've put a little dot in the canvas for where the drill is going to begin. I have the drill position. What else do I need? Well, I need a variable to keep track of the drill direction, like what direction is it currently drilling in, as well as the bias. Is the bias of the drill bit pointing up or pointing down? This is, again, a physical thing that's either flipped up or flipped down, +1 or -1. dir for direction, bias for bias. And I'm going to initialize the bias as -1. and the direction as a vector pointing horizontally straight. I mean, I guess we could start, maybe the drill should start pointing down. I don't know, what would be typical? You have to go, you can't go in the earth this way. So yeah, let's have it pointing down. So the simplest thing I could do right now would be to write a function, call it drill. And then in that function, I could add the direction to the position. And if I were to then call drill here in draw, which happens over and over again, you can see the drill is moving down. So obviously I need to add this idea of the bias and being able to steer it around. But before I even do that, I'd like to draw the full path. I think that will really help us in terms of visualizing the process here. I'm going to use an array, and every time I move the position, right before I move it, let's make a copy of where it was. That's essentially the previous position. It's very important that I make a copy because these are objects. If I just add the object directly without making a copy, I'm adding a reference to it. And then I just have many references to the same point. So when that point moves, they all move. Then in draw, I can use begin shape and end shape to connect all the previous points with a line. Loop through everything in the path. And you can now see this black line trailing behind the red dot. Now, instead of drawing that red dot, I'd like to visualize the drill bit so we can see what's going on and which direction the bias is pointing. So let me first just draw it as a line pointing down. And now I want to rotate it askew, up or down, or up, I don't know which way is what. But to rotate this line, I need to make use of transformation. Another topic that you may or may not be familiar with, but luckily for you, I have a whole set of videos about transformations in P5. Transformations come up anytime you need to rotate something. So I want to rotate by, let's say, pi divided by 6, it's like 30 degrees, times the bias. So positive or negative direction. Of course, you can see now that's way in the wrong place. This is where I need to translate to the point of origin to have the rotation work correctly. And there you go. So let's start it actually at entering in around 30 degrees. I can create a vector from an angle. Interesting. Let's try flipping the bias. Oh, let's add a button for that. So what this bit of code does is it creates a button, attaches a mouse pressed event to it, and whenever the mouse is pressed, that bias is multiplied by -1, making it positive or negative or vice versa. But look at that. The drill bit is not pointing in the direction that the drill is actually going. It's always just flipping left or right from pointing down. So we need to also incorporate the heading of the drill bit itself into where the bias is pointing. I've made an error here where I originally drew the drill bit pointing down, but all of the rotation and angles are relative to the horizontal axis. So for all this to work nicely, I should be drawing the drill bit pointing to the right. I also made another error, which is that the heading is the heading. The bias is affecting whether I'm rotating to up or down based on that heading. So I want to multiply the bias only by that offset, which is pi divided by 6. There we go. Now we can see the drill bit toggling between pointing up, down, up, down, up, down, up. Now, no matter what angle we start with, for example, 90 degrees, it's still going to work. I can even start from 0 degrees, and you can see I'm still able to toggle, and visually everything's looking right. I'm actually doing this live on Twitch, and the chat is asking a great question. Should we be using push and pop here? And I don't need to because I'm not drawing anything else after drawing the drill bit, but it would be really good to protect myself by using it. This translate and rotate will affect anything that comes afterwards. That drill function, don't let that mislead you. That's not drawing anything. But one, I might say logically, it might make more sense to put drill at the beginning and then put a push and pop around here. All right, I kind of went about this in a strange order because I really was working on just visualizing all these elements. The key here is actually taking the bias and having it affect the direction to which the drill turns. Remember, it's always turning. It's like a shark. It's always got to turn. It can't go straight. That's not what a shark does. The shark always keeps moving. You get the idea, though. This begs the question, how much does the drill actually turn? Now, I'm sure, again, there are real-world values for all of these things. I'm going to make up a value. I'm going to call it angle 0.01, a small incremental change. And I'm going to say direction, rotate by that angle times the bias. Oh, My drill, it's taking off to space. I have defied all the laws of physics. It's amazing. Let's have the bias pointing down to start. And now, here we go. I'm gonna try to toggle that bias. Curve back. I gotta get to the other side. Oh no, don't hit the water. Now, you can see if I just keep toggling it over and over again, that's essentially how I'm getting to go in a straight line. And can I make it to the other side? Come on, keep going. We did it! Horizontal directional drilling. Coding challenge complete. So what's next here? Certainly I shouldn't be allowing the drill to sort of orbit in this strange way. I need to add collision detection to see if it hits water. Maybe the scene should be procedurally generated and different every time. I could have an easy mode and a hard mode. If you're actually doing this in real life, you don't see everything underground and have a complete view of the entire world of what you're doing. So I would encourage you to take this as a code base and see how you can expand it. Share it with me on the Coding Train website. There's a form you can submit, links to your versions of horizontal directional drilling. But I also have made, hopefully not right now, but by the time you're watching this, a fully playable version of this game. That code will be on GitHub. I've made a list of all sorts of new features and ideas that could be added to this. By the time you're watching this, a lot of those will be implemented. Maybe there'll be some new ones. So come check out, play the demo, enjoy it, contribute to this, make your own version, share it with me, and see you next time on the Coding Train.